This is the last part of the lecture on steel and other metals. We have been discussing the general properties of metals, and then in the second part we looked at ferrous materials, steel and alloys of iron. Today we are going to look at non-ferrous metals, and to start with I have this picture of the Statue of Liberty, which as you know is now an emblem of the United States, and it is made out of copper on a steel framework, and it is said that the designer was Eiffel, who designed the Eiffel Tower in Paris. So, non-ferrous materials have also been used a lot in engineering. We look at some of the non-ferrous metals and their alloys that we use in buildings and other structures. Aluminium is one of the non-ferrous metals that is used a lot along with its alloys. Its specific gravity is 2.7, showing that it is a light material, and that is one of the reasons that we use it for cladding and roofing and so on. A melting temperature of 658 degrees, not very high, can be handled by a lot of small factories. Ultimate tensile strength of about 200 megapascal, modulus of elasticity 69 gigapascals. We see that the stiffness is less than that of steel. Pure aluminum is soft and ductile, and therefore, for usage in engineering it has to be alloyed with other metals like copper, magnesium, silicon and manganese, so that we get sufficient strength and hardness where it can be, with which we can use it. Aluminum in usage is generally coated in one of two manners. One process of coating called anodizing is where a layer of oxide is induced on the surface of the aluminum section. The thickness of this layer, depending on whether it is for external usage or interior, can vary from 5 to 25 microns, and one way of achieving this oxide layer is by dipping the aluminum section in dilute sulfuric acid, and for coloring the anodized surface various dyes are deposited in the anodizing process and stabilized within the oxide layer. So, we have a colored surface in addition to a corrosion resistant surface. A less expensive alternative is what is called powder coating. This is something like a paint, generally polyester is used, and this also gives color and gloss to the aluminum section. This has a lower life than anodizing, but also it can have several years of life in usage. Aluminum has many applications in construction, and these seem to be increasing. Aluminum is used in as cast fittings and grills. Extruded sections are used for partitions, frames of doors, windows and so on. We have a lot of aluminum used in cladding and also as foil for insulation. Aluminum composite panels are again quite common nowadays. They are made out of aluminum sheets bonded to a non-aluminum, generally a polymer core. This is frequently used for external cladding and for interior partitions. And to protect the aluminum and to also give a color, a coating of a fluorocarbon PVDF or polyester is normally given, and this gives the finish and the desired color. Aluminum roofing sheets are also quite popular because of the light weight and the corrosion resistance. So, there are a lot of sheets that are prepared to be used as roofing. Some sheets for roofing are made in multi layers. In some cases there is a steel core, external aluminum layers, and in between the aluminum and the steel layers we have bituminous layers. And the reason for using it is that the aluminum provides for insulation by eliminating the entry of radiant heat, it reflects off the heat, so that the heat does not get in, and then the bitumen gives additional protection as insulation against heat and noise, because otherwise you can imagine that if you have a metal roof, when it rains or something drops on it, there will be lot of noise. So, these multi-layer sheets not only give the stiffness and impermeability which is derived from the steel core, the aluminum layers now reflect off the heat. So, there is less heat getting into the roofing material, and the bituminous layers also cut out heat as well as noise. The general advantages in construction of aluminum, which is making aluminum be used more and more, is the high strength to weight ratio. As we saw, it is quite light and it is reasonably strong. So, the strength to weight ratio is in favor of aluminum. It has a very good corrosion resistance as opposed to steel and other materials, and as a replacement for wood, it has the obvious advantage that it cannot be attacked by insects. Termites will not attack, there will not be any fungus growth that we can see in wood. So, aluminum is replacing wood significantly for window and door frames. Similarly, we find aluminum being used for framework of partitions where traditionally wood would have been used. It is easy to maintain. Generally, the anodizing or the powder coating lasts for a long time, and it need not be periodically painted or maintained in any other special way. As we already saw, it has high reflectivity, this we will deal with in the slides that follow. It does not absorb radiant heat, it reflects off. Though it is a good conductor, it is used in insulation due to its high reflectivity. Since it is a relatively soft material, it is easy to fabricate and assemble aluminum sections and aluminum pieces. So, we already said that aluminum is used in insulation. This is through the use of foil, and the idea is that the radiant energy is reflected off, it does not get into the material. When we have a more traditional form of insulation like fiberglass, the insulation is provided by cutting off conduction and convection, that is the heat transfer by conduction and convection is cut off. However, they do not have any effect on the radiant heat, that is they do not reflect off heat. Generally these are rough surfaces, not shiny surfaces, so they do not have much effect on the radiant heat, and radiant heat transfer is very important, as important as conduction and convection on the temperature in a building, and in many cases it can become the most significant cause of unwanted heat loss or heat gain. Heat gain in the sense that heat from outside the building penetrates, or heat loss in the sense that you have a cold environment outside and you want to prevent heat loss from within the building through some artificial heating, and this heat should not be lost. Aluminum foil, as I said, reflects a lot of the radiant energy. It can reflect up to 97% of the radiant energy that strikes the aluminum foil, and therefore, it has become an outstanding component of insulation systems where some reflection is also incorporated. Reflecting foil insulation is generally composed of two outer layers of aluminum foil with some inner layer of an inert material, so that there is an air gap that provides for insulation against conduction of heat through the material. These are some pictures from the web, I have given the source at the bottom. This is an experiment showing a box coated with aluminum on the left and without the coating on the right. So, this is the aluminum foil that is placed around the box, and similarly at the top we have aluminum here, and here you do not have the aluminum. This is now a lamp which is providing heat, and we are seeing how much heat is transferred through the aluminum based insulation system. This is now just fiberglass, and this is probably aluminum exterior layers, and inside it would have the fiberglass. And here we see that the temperature is much cooler, 78 degrees Fahrenheit, whereas it goes up to 107 in this case. So, in addition to the fiberglass that provides for insulation by cutting off conductivity and convection, if we have aluminum on the surfaces, we eliminate the entry of radiant energy, heat is reflected off to a great extent, and we can have a more efficient insulation system. And this we can see in many products that exist. These are some rolls of aluminum foil insulation. You can see the shiny aluminum surface in cases where the aluminum is on both sides. Sometimes aluminum is only on one side because the other surface is not exposed. This is a case of an application in a partition where we can see the aluminum foil on the top. So, this could be the interior of the partition. There might be another layer of material on the outside, and on the inside we will have the aluminum based insulation to cut heat transfer through the partition. So, there are many products available in the market. These are combinations of bubble film. Bubble film is where you have a polyethylene layer with air gaps. This provides for insulation by cutting off conduction, and then we have the external layers of aluminum foil which cut off any radiant energy that could go through, and these are available in the market and can be used readily. Another non-ferrous metal that is used to some extent in construction is copper. Copper along with its alloys have been used in construction. Now, copper is used extensively as in electrical cables. However, in other applications it can be used where there is corrosion, there is a need to resist atmospheric corrosion, and therefore it has been used in buildings on the sea coast, industrial centers and so on. Traditionally in India it has been used a lot in temples. In other countries piping with copper is quite common. There are also applications of roofing with copper, and many ships have been made partially with copper. Recent research indicates that copper has an antimicrobial nature, and there is a lot of research going on to see where copper can be used in construction, so that in applications where this microbes, the cutting off of the microbes or the killing of the microbes is important, copper can be used in external surfaces or door knobs and places like that where there could be microbes and that could harm people, say in hospitals and so on. Some alloys of copper which are quite common are brass, bronze, and to some extent aluminum bronzes. Brass is an alloy of copper and zinc. It is stronger than copper and can be cast into molds. Traditionally, brass fittings have been used extensively for doors and window fittings, door knobs, hinges and so on. Bronze is an alloy of copper and tin. It is used a lot in India for making statues and other small items. Nowadays there seems to be an interest in using aluminum bronzes. Aluminum bronzes are alloys of copper with about 5 to 10% aluminum. They are stronger than both bronze and brass, and they have better corrosion resistance. So, aluminum bronzes are being used as cladding and also for fittings. Zinc for a long time has been used in the form of sheaths in roofing and other application. Zinc resists corrosion through the formation of a insoluble hydroxide layer on the exposed surface. So, it is quite resistant to corrosion. However, when placed in contact with iron, copper or lead, it corrodes very rapidly. You remember when we talked about the galvanic cell, we said that a material that was more anodic, when in contact with a material that is less anodic, will corrode preferentially. And this is one reason why zinc is used as a sacrificial anode. We talked about cathodic protection, where some metals are used as sacrificial anodes to protect the material that we want to have for a long time. This is one of the reasons why we use galvanized iron sheets, where iron or steel sheets for roofing are coated with zinc to increase the useful life. And what happens is this coating prevents water from coming in contact with the steel, and even if there is a scratch, the zinc will preferentially corrode rather than the steel corroding. Most GI sheets are made with hot dip galvanizing, that is, the sheet is cleaned by dipping it first in hot sulfuric acid bath and then dipped in 25% zinc chloride, and after partial drying in a molten bath of zinc. So, there is a coating of zinc given, and this coating, as I said, has two purposes. One is to prevent water from entering and getting into contact with the steel, so that the steel does not corrode, and secondly, even if the coating is scratched, which can often happen in roofing, the zinc will preferentially corrode. It will sacrifice itself to that to some extent to protect the steel and increase the life of the galvanized iron sheet. Lastly, we are seeing applications of titanium alloys. I showed you in the in one of the previous lectures when I discussed different construction materials that titanium cladding has been used in the Guggenheim Museum in Bilbao. The architect Frank Gehry chose titanium because of the surface texture and the surface reflectance of titanium. Titanium alloys have very high strength to weight ratios, and one of the titanium alloys that have very high strength is titanium grade 5. It has a yield strength of 828 megapascals, ultimate tensile strength of 900 megapascals, and a density of 4420 kilogram per meter cube. Titanium has been used as cladding using sheets of about 0.4 millimeters. So, the thin sheets can be used as cladding. It is corrosion resistant and has a low coefficient of thermal expansion. So, it can be used as cladding without experiencing a lot of strains due to temperature changes. So, these are some references. There are a lot of references which explain how steel and other metals have been used. We can also look at books based on material science, where again there is a lot of emphasis on metals and the properties of metals have been explained in detail. So, with this we conclude the lecture on steel and other metals used in construction. There is a lot of construction being done with metals, especially steel. In the next lecture, I have asked one of my colleagues, Dr. Arul Jayachandran, to talk about construction with steel, which though not popular in India, it is believed that it will become more and more popular because of the speed of construction and the durability that we can get with modern steel structures. Thank you.